Let's start with a cosmic paradox, one that should keep you up at night. Everything you see, everything you've ever touched, everything that makes up you, me, the stars, the galaxies, all of it is only about 5% of what's actually out there. That's right. All the normal visible matter we can detect accounts for just a tiny sliver of the universe. The rest, a whopping 95%, is a mysterious combination of dark matter and dark energy. We can't see it. We can't touch it. But we know it's there because we can measure its gravitational effects on the stuff we can see. It's the biggest mystery in all of science. So what is this invisible majority? For decades we've treated space as the ultimate void, an empty stage where the drama of matter and energy plays out. We call it space-time and describe how it can bend and warp. What if we've got it backward? What if that 95% isn't just dark stuff floating in emptiness? What if space itself is the main event? Imagine space not as a void, but as an active, energetic medium that fills the entire cosmos. It's the ocean, and we, the matter, are just the fish swimming within it. This changes everything. If space is an active player, then maybe it's responsible for some of the universe's most fundamental rules. Think about it. Light travels through space as a wave. Gravity travels through space as a wave. These aren't just properties of light or gravity. They are properties of the medium they travel through. Space isn't just a container. It's a participant. It has properties. It has rules. And if it's the dominant component of the universe, then its rules are the ones that truly matter. Now let's get to the nature of matter itself. In this new framework, what is a particle? Like an electron, like a proton. Let's propose a radical idea, the fixed shell hypothesis. Imagine a tiny, unchanging, rigid shell at the fundamental level, a discrete object, not a fuzzy probability cloud, not a point of infinite density. It has a fixed structure and a fixed size. Once formed, it does not stretch. It does not shrink. Its intrinsic properties do not change, no matter how fast it moves or what forces act on it. Some physics say mass increases near light speed, but what if that's a misinterpretation? With the fixed shell hypothesis, the shell itself remains constant. The effects we measure, like an increase in energy or momentum, aren't happening to the shell. They are happening in the active space around the shell. The shell is rigid. Any change comes from interaction with the external medium. It's a simple, elegant solution to a complex problem. Think of a bowling ball pushed through a tank of thick honey. The bowling ball itself doesn't change. It doesn't get heavier or bigger. The fixed shell hypothesis provides a fresh, intuitive explanation for two of the most fundamental forces we know, inertia, gravity. Let's start with inertia, the resistance an object has to a change in its state of motion. In our standard view, inertia is an intrinsic property of mass. But where does it come from? With our shell model, inertia is not an internal property. It is an external effect caused by the active space pressing against the shell. When you push on a shell to accelerate it, you're also pushing it against the surrounding space, which pushes back. This pushback from space is what we perceive as inertia. The simple and famous equation F equals ma, force equals mass times acceleration, still holds perfectly. M for mass is a constant measure of how much shell stuff is in an object. The force you apply creates the acceleration, but the reason it takes force is that you are working against the resistance of the cosmic medium. The shell doesn't gain mass as it speeds up. Instead, the resistance from space, the pile-up effect, grows exponentially, making it harder and harder to accelerate further. A massive object like a planet is just a huge collection of these fixed shells. Its presence causes a disturbance in the surrounding active space. It creates a sort of pressure gradient or a flow in the medium. A smaller object like a satellite doesn't get pulled by the planet. It gets pushed by the uneven pressure of the space around it, carried along by the flow created by the larger mass. A black hole becomes the ultimate example of this. It's an object with an immense number of shells packed into an incredibly small volume. The disturbance it creates in the surrounding space is extreme. The flow of space toward it is so powerful that it creates an event horizon, a point of no return. The gravity isn't a magical pull from the singularity at the center. It's the overwhelming rush of the cosmic medium itself. Gravity, in this view, is not a fundamental force, but an emergent property of the dynamic relationship between rigid matter and active space. If this model holds true, it completely revolutionizes our ideas about propulsion and the possibility of faster-than-light travel. And current propulsion methods are based on Newton's third law. For every action, there is an equal and opposite reaction. We throw mass out the back of a rocket to push the rocket forward. But this is incredibly inefficient. What if, instead of pushing against our own fuel, we could push against the fabric of space itself? If space is an active medium, then it's something we can potentially manipulate directly. Imagine a new kind of engine, a dual engine system. This ship doesn't have a rocket nozzle. One engine is at the front, another is at the back. The front engine forces the space ahead of the ship to become less dense or to move away, reducing the pileup of resistance. The rear engine does the opposite. It makes the space behind the ship denser or causes it to push forward. The ship itself doesn't accelerate through brute force. It creates a pressure differential, a controlled flow in the cosmic medium, and simply slides along within it. This changes the game entirely. The ship is a rigid shell, remember. It's not warping or bending. The engines are manipulating the space around the ship. This sidesteps the problem of relativistic mass increase because the ship isn't fighting against an ever-growing wall of spatial resistance. It's cleverly getting the space to move out of its way. The universe becomes a story about space, and matter is just a small part of that narrative. This perspective forces us to reconsider what matter even is. If space is the active substance, then matter might be something that interacts with it in a very specific way. Perhaps matter isn't some infinitely complex bundle of fields and particles at its core. Maybe it's simpler. Maybe matter is a sort of disturbance or a knot in the fabric of this active space. To understand the cosmos, we need to stop staring only at the 5% we know and start asking serious questions about the 95% we don't. That's where the real cosmic action might be happening. What if?